let's consider the convergence or divergence of the given series, negative 1 to the k, sine of 1 over k. Now this one's a little tricky. We see this negative 1 to the k and we'd like to think that it is alternating. But it's actually not technically an alternating series because sine can do some odd things. Right? Sine can be positive and it can be negative. We saw an example previously with a pi inside a cosine, and that made it go from 1 to minus 1, 1 to minus 1. The issue is that with 1 over k, that pi is not a constant multiple keeping us at one of the special points along the unit circle. This goes through the unit circle at a sort of an oddly paced step, and it's not always positive, negative, positive, negative. Sometimes it'll be positive for 3 terms and then negative for 2. Sometimes it'll be positive for longer, sometimes positive for shorter. It's not a regular alternating between positive and negative. So this is actually not an alternating series. And by that same argument, if I wanted to take the limit as k goes to infinity of k times sine of 1 over k, let's think about what's going to be happening with that. Well, these are going to infinity. The k part is going to infinity. What's going on with sine of 1 over k? As k goes to infinity, this becomes sine of infinity, right? This becomes sine of 1 over infinity, which is 0. So this becomes sine of 0. So this is actually infinity times 0. And so we're going to need to use our L'Hopital's rule again. So let's rewrite that as limit as k goes to infinity of sine of 1 over k over 1 over k. That's our favorite way of rewriting this. We'll bring the k down to the denominator. By doing so, this becomes sine of 0, and sine of 0 is 0, and 1 over infinity is 0. And so this is 0 over 0, and we can apply L'Hopital. Derivative of the numerator is cosine of 1 over k times the derivative of 1 over k. 1 over k is k to the negative 1, so the derivative is negative k to the negative 2, which is negative 1 over k squared. The derivative of the denominator is derivative of 1 over k. That's just like what we just talked about, so that's negative 1 over k squared. So we'll still limit as k goes to infinity. So negative 1 over k squared will cancel. So we're really just looking at the limit as k goes to infinity of cosine of 1 over k. As k goes to infinity, this goes to cosine of 0, and cosine of 0 is 1. So the limit of the terms is 1. Limit of ak is not 0, so by divergence test, the series diverges.